Hi, and welcome to another edition of Math with Mr. Douglas. Today, we're going to be looking at simplifying radicals, but this time, we not only are going to have numbers as a radicand, we're also going to have variables in there as well. So we'll take a look at that, and in the challenge section, we'll take a look at quadratics and how that plays out with radicals. Alright, let's get to it. Okay, so we're talking about radicals today, and we're going to be looking at how to simplify radicals with numbers and variables in the radicand. So a quick little review. Here is our radical symbol, and of course we have the index, which by default is a 2, so square roots, and we also have stuff that goes inside the square root, and we're going to call this the radicand. So before we were looking at things like what's the square root of 9, but now we're going to add in variables. So let's say I had an x squared in here as well. So that's what we're going to be looking at today. And a quick little summary, if you're taking the square root of, let's say, the square root of 9, and remember that means what number times itself will equal 9. And of course, I think you guys know that it's 3. But it's not just 3, it's plus or minus 3. So it's really important, especially today, that you guys get that into the habit of showing that. Because negative 3 times negative 3 is a positive 9, and positive 3 times positive 3 is also 9. So get into the habit of showing that. Some people like to put the plus and minus sign right here by the square root sign, and just kind of realize that that's what we're getting here. Okay, let's talk about what happens when we take the square root of something that is squared. Okay, well, this, maybe even taking a step backwards, so we're going to take a step backwards. And remember, to get x squared, how do we get there? We went x times x. Now remember, there's a little exponent here of 1. So that would mean x to the power of 1 plus 1, which is x squared. Okay, so that's how we got to that x squared in the first place. When you take the square root of something, you have to ask yourself what number times itself would give you this value. So taking a look at that, if I broke it down, x times x, which is itself, would give you x squared. So the square root of x squared is x. Let's put everything together now, shall we? So let's say we had the square root of 9x squared. Well, how I like to think about this is in two separate parts. Deal with the coefficient there, the 9. So you know the square root of 9 is 3. And then what's the square root of x squared? It's x. So the square root of 9x squared is 3x. Well, that seems all pretty good. What if you had situations like the following? So let's go and I'm going to grab my eraser. I'm going to magically erase this now. It's just fun to use an eraser. There we go. And let's say we had something that was a little bit harder. Let's say we had 20 and x to the 4th. So we're going to have a couple of different things going on here. And I'm going to intentionally put the index shown right here. This is going to be really important. So first off, we're going to deal with that 20. So with that 20, remember you got to think about what are two numbers that multiply to give you 20, where 1 is a perfect square. And hopefully you're thinking 4 and 5. So that's what that would be, and you know that the square root of 4 is 2. So this part here would give you a 2 root 5. But don't forget, we still, inside, have an x to the power of 4. Again, you need to think about, and I'll put the index there just to remind us, because that's going to come up in about 31 seconds. what number times itself would give you x to the fourth? Well, you need to be thinking of, probably you're already kind of thinking of maybe, an x squared times an x squared would equal x to the power of 2 plus 2, so x to the fourth. So you kind of say, okay, so that's what it's going to be. But an easier way to think about it, and you got to kind of go with me here, is you take the 4 and you divide by the index. It's a really quick and easy way to do it. And so you go 4 divided by 2, boom, the answer is squared. So it's going to be x squared. So my final answer, and I'll use a nice color of red, would be 2x squared root 5. Okay, let's kick it up one more notch, and we're going to go back in time, dare I say, go down the rabbit hole, and we're going to go all the way back to grade 2. Grade 2 was a great time. You had recess, you went on slides, you got to play with blocks, maybe you did some finger painting. Grade 2 was awesome. And we're going to take a look at the following. What's the square root of x to the power of 5? And I'm going to put the index here again, and we're going to use the same idea that I just said, is to quickly get to the answer, you have to go 5 divided by 2. But when you did 5 divided by 2, you know that it's not going to be a nice clean number. You're going to get some kind of a decimal answer. But I want to stay in grade 2. Oh, excuse me there. I want to stay in grade 2. So in grade 2, when you did dividing, so if you went 5 divided by 2, you probably learned something with a kind of long division like this, and 2 goes into 5 twice. You multiply back, you get 4, and you get this 1. Now in grade 2, what did you call that? I believe you called that the remainder, didn't you? And if you had a teacher, then you put the answer is 2R1. And that's what you kind of said. So it's 2 remainder 1. Very cute. So we're going to use the exact same idea here. If I go 5 divided by 2, you know that is going to be 2 remainder 1. Well, the remainder kind of tells you, what gets left inside the radical symbol. So that's what's left inside. And the two of them kind of come on the outside. So the square root of x to the 5th, I'm going to take 2 of them on the outside, so x squared. And what's left inside? Remainder 1. So 1 remains inside. Now, if you want a more mathy kind of explanation of that, a more mathy explanation, so I'm just going to take this question, I'm just going to go over here, is I want to think of 2 numbers that multiply to give me 5, where 1 is a square number. So it's a little bit different because when you multiply exponents, you're actually adding. But if we, oops, why not do that? If we said, well, what 2 numbers could they be? You basically want to get an even number. So if I said x to the 4th times x to the 1st, would that give me where a number is an even number so I can take the square root of it really easily? Yeah, for sure. You could with 4. And remember that x to the 4th times x to the 1st is not 4 times 1. Remember, we add the exponents. We add them when we multiply. So that is x to the 5th. So when this happens and you take the square root of x to the 4th, the square root of x to the 4th is x squared. And you still have this here, so it's still just root x. You can't take the square root of that one. So that's kind of the math version of it. You have the kind of grade 2 version of it. Whatever works for you. But you need to kind of know that idea for us. Let's go and take a look at a couple other things. So we've talked about square roots quite a bit. But I also want to be talking about cube roots. I think that would be pretty cool. And maybe we'll do, should we do one more? Let's do one more of kind of a fun one, just to make sure we're all good. Let's take the square root of 40x to the 7th. Ooh, Actually, you know what? I'm going to kick it up even further. X to the 7th, y squared, z to the 5th. What just happened, Mr. Douglas? This became a crazy question. Not at all. Fear not, students. Let's take the square root of 40. So two numbers that multiply. So hopefully you're thinking 4 and 10. So the square root of 4 is 2. So 2 is going to go on the outside. We know that. And 10 is going to stay on the inside. Well, we still have all of this stuff to deal with. Deal with each letter individually. The square root of 7, of a 7 exponent. So I'm going to divide by the index, which is 2. 7 divided by 2 is 3, remainder 1. So 3 are going to go on the outside, and it's going to leave 1 on the inside. What's 2 divided by 2? Just 1, so 1's going to go there, and there's no remainders. And 5 divided by 2, you just saw that, it's 2 remainder 1. So we'll squeeze that in there, and 1 is left inside. Whew, that was crazy, but this should give you like a giant, like, woohoo, things are good. Okay. Let's take a look at cube roots. So cube roots, remember, same idea. But what number times itself 3 times would give you the number inside? That could give you the radicand, basically. So you know the cube root, sorry, of 8 is 2 times 2 times 2. So really getting to know cube numbers is really important in memorizing some of the basic ones. We're going to do the exact same kind of idea here that we just used, but this time we're using obviously cube roots. So if I asked you, what's the cube root of x to the power of 9? So remember I said you're kind of you're dividing the exponent here by the index. So what's 9 divided by 3? Well, it's just 3. So we would get the cube root of x to the 9th is x to the 3rd, just like that. Does the remainder thing still kind of work? It sure does. Let's just take a look at what that might look like. I want to know what the cube root of x to the let's go. Whoa, what just happened there? We just got kind of an email notification. That was exciting. Let's get rid of those. Where were we? So x to the power of 20. Let's go x to the power of 20. So what's 20 divided by 3? It's 6. And what's the remainder? Remainder 2, I believe. So x to the 6th would go on the outside. And we still have 2 left on the inside. And remember, we're talking about cube roots, so we have to make sure that we're showing that this is a cube root. That is very important. Should we break this one down a little bit? Yeah, let's go and do that. So I want to know a number times itself 3 times because we're talking about cube roots. So if I did, x to the 6th times x to the 6th times x to the 6th. So it's all 3 times there, right? There we go. It's pretty exciting. But we don't get to 20, don't we? 6 plus 6 plus 6, 18. We need a x squared. So I can take the cube roots of these because they divide by 3 really nicely. And the cube roots of x to the 6th is just going to be x squared. So there's 3 of those. That's why this adds up to 6. But we've got to keep the x squared still inside there because nothing can happen. You can't take a cube root of a square number. So that kind of gives you the idea for that. Let's put this all together. For one last thing, here we go. I'm going to go and get a nice blank canvas. And let's get rid of that one. And here we go. Yeah, are you ready? This is going to be exciting. What is the cube root of 32 y to the 10th? Dun dun dun. Okay, so the cube root of 32. You know that 32 is not a cube number. But can you think of two numbers that multiply together to get you 32, where one is a cube number? So those cube numbers, you really do need to know those ones. And I'm going to give you a little hint. It's going to be 8 and 4, 8 being the cube number. So the cube root of 8 times the cube root of 4 will give you the cube root of 32. So the cube root of 8 is 2. So this answer is going to start off with a 2. And that 4 is going to be here. And don't forget, we need to show the index for this one for sure, because we're talking about cube roots. But what about the cube root of y to the 10th? Again, divide it by 3. And you can get 3 remainder 1. So that y will go on the outside. So it's y cubed, but there's still a remainder left inside. There you go. 2y cubed times the cube root of 4y. Whoa, that is awesome. That is so awesome. You guys are going to get, that's right, my little bear. I like my little bear. There he is. Got to give him the little ears. There he is. And he's got a big belly. There we go. He's happy. He's a happy bear. He's like, good job, everybody. Good job. Maybe some buttons. Sometimes I have too much fun doing this. And there we go. Excellent job on simplifying radicals with numbers and variables in the Radican.
Okay, it's time for some challenge work. So we are going to be looking at quadratic equations and how to solve quadratics, finding the square roots. Sounds exciting. Let's get to it.
So let's talk about quadratics for a second. And quadratics are going to be a little bit different than what you may be used to. You're probably used to looking at linear equations. So these are going to be equations. So like mx plus b sort of thing. And the big thing is, kind of in student language, the linear equation is a straight line, obviously. But the exponent is only to the power of 1. Whereas when you're dealing with, say, quadratics, you are looking at things raised to the second. So like an x squared plus 5x, say minus 2 equals 0. So quadratics will give you basically those parabola sort of things. Sometimes I'll make them into a happy face because that's just fun to do. And the linear stuff that you're probably more used to is where you just have like straight lines and you're graphing those. So we're going to talk about quadratics. So kind of think about, these are things that have like x squares. We're going to be using or solving with square roots, so the power of square roots. So a couple of reminders. If you take the square root of something, you always get kind of like a plus or minus 2. And if you take the square root of something that is already squared, you basically get itself. So the square root of x squared is just simply x. And obviously vice versa. We can go backwards with that whole process as well. So let's get to it, shall we? The first thing we're going to look at is x squared minus 4 equals 0. So most kind of quadratics are actually set to 0, so equaling 0. And you still want to be asking yourself, how do I get x all by itself? Well, a couple of things. Number one, this is an x squared. So that should tell you right away that you need to be using the square root. And using some good algebra, we want to go and make this, so it's simply the x squared equals everything else. So let's just go and add 4 to both sides. And let's see what we end up getting. So we end up getting x squared equals positive 4. And if we want to get x all by itself, I need to use the power of the square roots. So the square root of x squared is simply x. And of course, the square root of 4 is plus or minus 2. So that means I can put plus or minus 2 inside this, and that will equal that. Does that make sense? It sure does. It sure does if you go and check your answers which is always a good thing to do. Let's take a look at this one. This one's a little bit trickier. And whoa, there's the old stuff. Let's get rid of that, shall we? Let's get rid of that, and let's just throw this on here. Let's take a look at, in brackets, an x minus 5 squared minus 100 equals 0. Okay, now this is a great question to look at. Again, we're going to follow the exact same idea as the previous one, so I'm going to add 100 to both sides, use all my good algebra knowledge, and that just leaves me with an x minus 5 all squared is equal to 100. How do I get rid of something that is squared? I take the square root. So I'm going to take the square root. And when I do that, I'm left with just purely x minus 5 is equal to plus or minus 10. Now that plus and minus is going to become very important because there's two different situations. There's one situation where you get x minus 5 equals positive 10. But there's another situation where you will get x minus 5 equals negative 10. So you have two different situations that you need to go and solve. So dealing with the first situation, I'm going to add 5 to both sides. So x would just simply equal 15. And over here, I'm going to still add 5 to both sides. And you're going to end up with x being equal to negative 5. So you get two answers. And those are going to be values of x. So when we start graphing parabolas, this will make more sense. But for right now, we're just trying to figure out what the possible answers are. So 15 and negative 5. Now, being good students, you're going to go and put those into this equation and check your answers. So let's go and check. So remember, our equation was x minus 5 all squared. Oops, it's just minus 100. There we go. It's going to be minus 100 equals 0. And I believe we said the answer was, what was the answer again? 15 or negative 5. So 15 or negative 5. So I'm going to try putting 15 and negative 5 in here. So let's try the very first one. So the very first one, I'm going to put that 15 right there. And I'm going to go minus 5, basically all squared, minus 100. This blue or purple is pretty trippy, isn't it? 15 minus 5 is 10. So 10 squared is 100. Is 100 minus 100 0? It sure is. Let's go try the next one. So the next one, I'm going to go and put that negative 5 in there. So if I said negative 5 minus 5, what's negative 5 minus 5? It's minus 10. Minus 10 squared is 100, and 100 minus 100 is 0. So that is also correct. So our solutions is 15 and negative 5. You're on your way for understanding quadratics. Let's take a look at something maybe a little bit more trickier. I'm going to show you a couple more examples to kind of get you going a little bit. And this will hopefully set the stage for you to go and tackle some of your own questions. Let's take a look at 25x squared minus 7. And I really like this question. This is kind of fun. This is where the geeky math teacher in me comes out. So 25x squared minus 7 equals 0. Because it looks like there's a nice little simple question that you have here, but some fun things are going to happen. Let's go and add 7 to both sides. And what does that leave me with? A 25x squared equals 7. It's an ugly square. There we go. Equals 7. And I'm going to divide both sides by 25. Because I want to get x squared all by itself. Now, there's a couple other ways that you could probably do this. I'm going to show you this way because I want to show you something specific for this one. So when I went and did that, that eliminates my 25s. And that will leave me with an x squared equals 7 over 25. Now again, we're going to take the square root of both sides. I'm going to rewrite this using some of our radical knowledge, perhaps. And I'm going to rewrite it like this, which we're allowed to do. X is equal to the square root of 7 over the square root of 25. This becomes pretty important for a variety of reasons. I can take the square root of 25, can't I? Sure, we can. And because the square root of 25 is plus or minus 5, kind of my answer ends up being plus or minus the square root of 7 over 5. That was kind of fun. Let's take a look at one more, kind of the really killer question here. So watch how I write this one. It's pretty important. It's this square root of x minus 1. So I'm putting it really far away. So that minus 1 is not part of the square root at all. It is equal to the square root of x minus 7. Whew, a lot of things going on here. So we need to take a step back and we need to go and remember something. We need to remember FOIL. So this is when you're multiplying two binomials together. So when you have things like x plus 2, let's say times x plus 2. This will be a good example. So x plus 2 times x plus 2. So if you're really thinking about, well, does he just mean x plus 2 all squared? I certainly do. So that's what we're doing. I'm just going to show you this using FOIL. So FOIL stands for first, outside, inside, last, which means the first numbers multiply, the outside numbers multiply, the inside numbers multiply, and the last numbers multiply. And what does that give us? That gives us an x squared plus 2x plus another 2x plus 4. Combine my like terms, and I get x squared plus 4x plus 4. There is a shortcut to do this. I love this shortcut. I learned this, I think, in grade 10 when I was back in Canada. If you're squaring a binomial like this, it's very simple. You square the first term, x squared. You multiply these two terms together, and then double it. So what's 2 times x? 2x. If I double 2x, what is that? 4x. There's 4x. And then you square the last term. 2 squared is 4. And you go straight to the answer. So if you can memorize that, it'll speed up things a little bit. So why do I talk about this? Well, I'm glad you asked. Because I need to go and I need to square both sides. So that's what I'm going to need to go and do. So I'm going to square this side, and I'm going to square that side. The right-hand side is nice and easy. The square of a square root is simply the number itself, so x minus 7. But over here, I'm now squaring a binomial. Let's go and use that shortcut. I'm going to square the first term. So if I square the square root of x, does that sound weird? I'm going to square the square root of x. That's just going to be x. I'm going to multiply these both together. The square root of x times -1 is a negative square root of x. I'm going to double it, so it's going to go from 1 to 2. So this is going to be minus 2 root x. And I'm going to square this. I'm going to square -1. So it becomes positive 1. Okay. Let's go and solve some stuff using our algebra knowledge. Well, I'm going to subtract x from both sides. So I'm going to get rid of the x. Boom, boom. I can do that. I'm going to subtract 1 from both sides. And that is going to leave me with a -2 root x is equal to -8. I'm going to divide both sides by -2. Whoop. Whoop. Love that sound effect. And I am left with the square root of x equals 4. That is an equal sign. There we go. The square root of x equals 4. Well, how would I So just kind of think about this right now. How would I go and do that? Well, now I got to go and square again. So if I square both sides again, I will be left just with an x, won't I? And the square of 4 is 16. Now, let's go and check our answers like good students. I know students never like to check their answers. I love your confidence, but we need to go and put x into here and put x into here. That keeps popping up. It's kind of funny. Okay, so here we go. If I put 16 in there, what's the square root? So what's the square root of 16? 4. What's 4 minus 1? 3. What's 3 squared? 9. Okay, so we're getting 9 there. We should put a big 9. Woo! If I put 16 here, 16 minus 7 is also 9. The square root of 9 is 3. 3 squared is also 9. Does this all work out? Yes. And you get the happy bear. Yes, we're going to give you the happy bear. Here's my little bear. There he is. He's happy. Excellent job. So you've seen a little bit about quadratics. I'm emphasizing checking your answers because there will come a time when a teacher will give you a question that when you check your answers, it doesn't work out. And when it doesn't work out, it's no solution. And we haven't talked too much about what no solution really means, what it looks like with quadratics, but realize it's out there. It can happen at any time. So it's really important that you do check your answers. Okay, well done. Give yourself a big pat on the back.
Thanks for watching, everybody. Hopefully you picked up a little bit about how to simplify radicals and also the wonderful world of quadratics, one of my favorite topics. Till next time.